Hello everyone, I am Nishant from Sri Venkateswara College of Engineering. Today I pick the subject is analysis of data, design and algorithm. Introduction to sorting algorithm. Sorting is a fundamental operation in computer science where data elements are arranged in a specific order. Sorting algorithms are essential tool for optimizing data storage, retrieval and processing. This session will provide the high-level overview on importance and key concept of sorting algorithm. First, insertion sort. Insertion sort is a simple and efficient sorting algorithm that works by irretrievably, irretrievably building a sorted subarray from the input array. It is comparison based algorithm that works by gradually building a sorted portion of the array by sorting element from the unsorted position into the correct position. Here are the steps to perform insertion sorting. Start with the first element as the sorted region. Take the next element from the unsorted region and compare it with the element in the sorted region. Third step is insert the element into the sorted region at the correct position. Fourth step is repeat the process until the unsorted region is empty. And the last fifth step is the sorted region now contains the entire input list. Here an example of how insertion sort work. Suppose we have the following input list: 89, 45, 68, 90, 29, 34, 17. First iteration for I is equals to 1 to 6, V is equals to 45, J is equals to 0, while 0 is greater than or equal to 0 and 89 is greater than 45, it is true. A of J plus 1 is equals to A of J, so that A of I, A of 1 is equals to A of 0 of A of 1 is equals to 89. J is equals to 0 minus 1 means minus 1, while minus 1 is greater than or equal to 0, so that is false. E of 0 is equals to 45. Array, it sorted 45 from the position of that array position. Next, the second insertion iteration is for I is equals to 2 to 6. V is equals to 68, J is equals to 1, while 1 is greater than or equal to 0 and 89 is greater than 68, it is true. E of J plus 1 is equals to E of J, so that E of 2 is equals to E of 0 of E of 2 is equals to 89. J is equals to 1 minus 1 is equals to 0, while 0 is greater than equal to 0 and 45 is greater than 68. It is false. E of 1 is equals to 68. So that the array position will be sorted from 48, 68, 89. The third iteration is for I is equals to 3 to 6. V is equals to 90. J is equals to 2. While 2 is greater than or equal to 0 and 89 is greater than 90. It is false. A of 3 is equals to 90. Then the array will move to 48, 45, 68, 89, 90. Then the fourth iteration is for I is equals to 4 to 6, V is equals to 29, J is equals to 3, while 3 is greater than or equal to 0 and 90 greater than 29. It is true. E of j plus 1 is equals to E of j, so that E of 4 is equals to 90, j is equals to 3 minus 1 is equals to 2. While 2 is greater than or equal to 0 and 89 is greater than 29, it is true. E of j plus 1 is equals to E of j, so that E of 3 is equals to 89. J is equals to 2 minus 1 is equals to 1, while 1 is greater than 0 and 68 is greater than 29. E of j plus 1 is equals to E of j, so that E of 2 is equals to 68, j is equals to 1 minus 1 is equals to 0, while 0 is greater than 0 and 45 is greater than 29. It is true. Therefore, E of I plus 1 is equals to E of I, so that E of 1 is equals to 45. Then j is equals to 0 minus 1 is equals to 0. While minus 1 is greater than 0, it is false. E of 0 is equals to 29. Then the array becomes 29, 45, 68, 89, 90. Then the fifth iteration is for I is equals to 5 to 6, V is equals to 34, J is equals to 4, while while 4 is greater than 0 and 90 is greater than 34, it is true. E of j plus 1 is equals to E of j, so that E of 5 is equals to 90. J is equals to 4 minus 1 is equals to 3, while 3 is greater than equals to 0 and 89 is greater than 34. It is true. E of j plus 1 is equals to E of j, so that E of 4 is equals to 89. J is equals to 3 minus 1 is equals to 2, while 2 is greater than 0 and 68 is greater than 34. It is true. E of j plus 1 is equals to E of j, so that E of 3 is equals to 68. J is equals to 2 minus 1 is equals to 1. While 1 is greater than 0 and 45 is greater than 34, it becomes true. E of j plus 1 is equals to E of j, so that E of 2 is equals to 45. J is equals to 0 minus 1 is equals to 0, while 0 is greater than 0 and 29 is greater than 34. It is false. E of 1 is equals to 34. Then the array becomes 29, 34, 45, 68, 89, 90. Then the last iteration is for I is equals to 6, V is equals to 17, J is equals to 5. While 5 is greater than or equal to 0 and 90 is greater than 17, it becomes true. So that E of j plus 1 is equal to E of j, so that E of 6 is equals to 90. J is equals to 5 minus 1 is equals to 4. While 4 is greater than or equal to 0 and 89 is greater than 17, it becomes true. E of j plus 1 is equal to E of j, so that E of I, E of 5 is equals to 89. J is equals to 4 minus 1 is equals to 3. Same, the steps will go on until while 0 is greater than 0 and 29 is greater than 17. So that it become true. E of 1 is equals to 29. J is equal to 0 minus 1 is equals to minus 1. While 1 minus is greater than 0 becomes true. E of 0 is equals to 17. Then the array becomes sorted. It, it becomes 79, 17, 29, 34, 45, 68, 89, 90. Then we go to the next topic, insertion sort efficiency. Insertion sort is a simple sorting algorithm that builds the final sorted array one item at a time. Its efficiency is based on its ability to efficiently sort small array or a partial sorted array. Insertion sort has a time complexity of big O of n is n to the power 2 in the worst case scenario. The best case scenario of insertion sort is best case time capacity for insertion sort is big O of n when the array is already sorted. In this scenario, the algorithm only compare each element with its adjacent element and moves on the next element. This makes the insertion sort highly efficient when dealing with nearly sorted array. Summary of the insertion sorted. Insertion sort is a simple and efficient algorithm for algorithm small data set or a partially sorted array. While it may not be the most efficient for a long data set, it has its advantage in a specific scenario. Understanding the efficiency and the limitation of insertion sorted can help in choosing the right sorting algorithm for the different tasks. Next, introduction to topological sorting. Topological sorting is a method used to order the vertex of a directed acyclic graph of TAG in a linear order. It ensures that for every directed edge from the vertex U to vertex V, U come before V in the order. This ordering is useful in scheduling the task, resolving the dependency, and optimizing the operation. Understanding the directed acyclic graph DAGs. DAG graph is a graph with a direct edge and no cyclic. In a DAG node are arranged in a way that there is a consistent direction of a dependency between the nodes. Topological sorting is only capable to DAG as it's require a linear ordering for node without any cycles. Depth first search algorithm overview. Depth first search is a recursive algorithm that explores as far as possible along each branch before backtracking. It uses stack to keep a track on to visit and mark each visited node to avoid a revisit them. TFS is commonly used in a graph transversal topological sorting and finding connected com- component in a graph. These are the vertex, adjacent vertex, and swapped vertex. This is the insert. This is the topological sorted picture. First, we sort D, and next is A, next is C, and B, next is G, and F. The last is E. Source removal method for topological sorting. In the source removal method, we repeatedly remove the node with no incoming edges from the graph. The removed node from the topological order of the graph. This method is efficient for topological sorting a DAG and can be implemented in a linear time capacity. This is the graph picture. First step, we remove the D, and this is the graph in this step, topological order D. Second step, A will be removed. Then the topological order is DA. Third, in the third step, we remove the B, and then the graph will be looks like CFGE, and the topological order DAB. Then the fourth step is removal of C. By removing of C, there will be three nodes. Then the topological order is DABC. Then the fifth step is removal of G. By removing of G, there will be two nodes. Topological order becomes DABCG. Then the sixth step is removal of E. Then the topological order becomes DABCGE. This is the topological order. We have the topological order in an order of DABCGEF. Thank you.